about the evolution of language. We've talked a little bit about the neuropsychology of language and kind of a introductory lecture on different aspects of language. And today we're going to talk about how it might be possible, or a few different theories on how language evolved within primates. So I'm going to go through several different theories and kind of talk about some of the major concepts and thoughts behind those theories and the persons involved in those particular theories. So the first one that we're going to look at is by a person named Merlin Donald. And Merlin Donald wrote a book back in '91 called The Origins of the Modern Mind. And he talks a lot about different memory systems and how different memory systems evolved within the primate lineage, and how those memory systems could be involved in or related to how we evolved the possibility for language, and even kind of thinking maybe more broadly in terms of a communication. So he talks partially about memory systems, and he talks about other cognitive and psychological functions that evolve that may contribute to how language evolved. So the first part is known as episodic culture. Episodic culture. And this is a precursor, or this is kind of what was going on in our lineage prior to stage one. I mean, these are things that were shared with other primates. And as you remember, in terms of episodic memory, episodic memory within early primates was limited to individual episodes. So at this stage, persons could remember certain events in their own lives, but they were still limited to the immediate time frame. So their memory was much more individually focused and limited in terms of time space. So early primates were able to form certain kinds of representations, but they were unable to reflect upon them individually or collectively. And we'll see as we move on that language and communication is about how our lineage began to share certain things with each other in terms of communication and for language. So during this precursor stage, there was no way to really share information between each other. So the first stage, as Donald sees it, is called the mimetic culture. Mimetic culture, and this is when imitation becomes a basic mode of cultural transmission. And by imitation, we're talking about the way in which we can imitate the behaviors, facial expressions, so on and so forth of other persons. So this early form of mimicry allowed us to share certain kinds of representations with each other. So at first, early forms of mimicry was the attempt to simply duplicate the behavior of the other. So it's kind of like the way in which a mother will imitate exactly what a young child or a young baby, the facial expressions of that baby. And so a lot of early tool use might have been this type of mimicry where someone would observe someone doing something using a certain kind of tool, say for instance a rock, in a certain kind of way, and then would simply imitate and do exactly the same thing. So it's a way to share certain kinds of things. So mimicry is more related to the exact representation, doing the exact thing that someone else has done. But later stages involved imitation. And so imitation occurs when you could do certain kinds of innovations based on the observed behavior. So you could observe what someone had done, you could imitate it in a certain way, but then you could add your own thing to it. You weren't limited to just copying exactly the behavior. You could modify it or innovate it in a certain way. And that's what led to different forms of imitation. Now, one of the neural factors involved in this process could be mirror neurons. And so mirror neurons are neurons that were discovered in the macaque monkey in the area of their premotor cortex, area F5. And these particular neurons actually fire when the macaque is observing someone doing something, and then when they perform that same kind of action. So mirror neurons may be a kind of neural mechanism that enables or facilitates different types of mimicry and different types of imitation. So electrical activity in this early research was recorded in 532 neurons, and the activation was associated with both observing someone doing something and executing those same types of behaviors. The same neurons fired both when watching someone and when doing that same thing that was being seen. Other research has showed other areas that may have certain mirror properties or mirror neurons, such as the PFG area of the lateral parietal lobule and the interparietal sulcus. But the important part here is that within the primate lineage, it's probably the case that part of what allowed us to imitate each other was the development of these mirror neurons. And the mirror neurons were kind of a basic part of our neural anatomy. Now, when we move on from imitation, we move on to what are called shared intentions. Shared intentions. And sharing intentions is the ability to not just observe what someone else is doing and innovate on it, but then the ability to understand what is the intention behind that particular action. Meaning, what is someone trying to actually what are they trying to accomplish as they are doing something? What's the intent of the behavior that they're doing? And what shared intentions allow us to do is, once again, add to that modification. So that if I know what you're wanting to do, I can do that same thing. I can imitate your behavior, or maybe I can go about trying to achieve your goals in a different way. And that's what shared intentions allow us to do, allow us to, in a sense, know the thoughts of other persons. So shared intentions is necessary for engaging in uniquely human forms of collaboration. It's a stage in which there is now a plural subject, a we. So we have a group, have certain kinds of intentions, and we can share those with others. We can have joint goals, mutual knowledge, and shared beliefs. This is all in the context of cooperative motives. So this allowed for groups to actually think as a group and not just individually, not just completely selfishly. So this is kind of one of the basic ways that we learn to step in to the mind of another person. Now, one of the basic cognitive functions related to this is a theory of mind. And theory of mind is the development starting at about age 4, when we begin to develop the ability to understand and think about the thoughts of others. So theory of mind is a basic aspect of human cognition, and it's the way in which we interpret the intentions and goals of other persons. It usually develops around age 3 or 4. And theory of mind, because it's so basic to our cognitive makeup, it allows us to naturally view others as intentional agents, meaning that we realize as a species that when a person is doing something, they're not just doing those things for no good reason. There's an intention or a motivation behind it. And as we become better at theory of mind, we can begin to understand what someone is doing, or what their intentions are behind what they're doing. What are the cognitive reasons, or what is the motivations behind what it is that they're trying to do? And so theory of mind is something that we develop really quickly, and obviously it would have been important for human evolution, because being the social species that we are, you have to know what someone's intentions are behind what they're doing. both in terms of if you want to join them, in terms of a cooperative type of venture, or to sniff out people who may have bad intentions and who maybe aren't as, uh, who maybe might be up to things that aren't necessarily in your best interest. So when we move on to the work of Terence Deacon, we're kind of leaving Merlin Donald behind. We've kind of seen some basic changes that occurred in human evolution and in human primate evolution in terms of shared intentions, in terms of imitation, in terms of theory of mind. And Terence Deacon has taken some of these things as well and developed what he calls the idea of a symbolic species. So humans evolved language abilities as we evolved the ability to understand different kinds of symbols. And that this symbolic nature that is a part of human beings is what allows us to have language. And really what allows language to take on the more abstract properties that it has, so that things can stand for something in a more abstract, theoretical, or conceptual way. So Terence Deacon is an anthropologist, kind of a cognitive anthropologist at UC Berkeley, and he believes that humans' enlarged frontal lobes actually leads to the development of symbolic processing. If you look at one of the unique parts of the human brain that's really what different from all other primates is how much larger our prefrontal cortex is in comparison to other primates, and even other animals. A lot of other animals have bigger brains than we do, meaning the size of the brain itself is actually larger. But it seems to be the case that it's not a larger brain, but it's the amount of processing power you get out of the brain that you have. So if you look at a human brain and the way in which the gyruses are kind of all pushed together and formed together, it's that complexity of neural connections, especially in the frontal lobe, that leads to our ability for symbolic processing. So symbolic processing allows for language and other types of abstract thought, and the enlarged frontal lobe in humans provides more interconnections between different areas of the brain. So the frontal lobe internervates with several other parts of the brain that allows for symbolic processing to play a larger role in our everyday behavior. So it allows us to not get caught up in the stimulus to drive behavior. And what that means is, there's a lot of times when human behavior and even animal behavior is simply stimulus to a particular action, meaning something happens and we react to it. So for example, my dog, when he hears the yard people coming, he knows when they're coming because he can hear the sound of the lawnmowers going, and he immediately simply reacts to it. He starts barking really loudly and goes kind of nuts. That is the stimulus to drive behavior. There's something that happens, and he can't help but react to it, and in a more emotional and obviously out of fear sort of way. So what symbolic processing allows us to do is to, in a sense, stop or make a pause in that kind of behavior. It allows us for more ability to think through what it is that we want to do and not simply react to the environment without any thought involved or without any planning or goals involved. Now, Deacon's theory relies on the work of a philosopher whose name is C.S. Peirce. And Peirce had a certain theory about different kinds of representations or the way in which something can represent something else. And so he had what's called a theory of signs. And so signs are something that stands in for something else. So it's the way in which we can take one thing and it can mean something else. Now, the way in which something means something else has different properties behind it. So there's different kinds of things that can stand in for something else. But the important part of a sign is that it creates an equivalent sign in the mind of another person. So the important part of a sign is when I show the sign, say like a letter, like the letter A, it represents something to you that you know the same. You know what an A is. We can share that idea of what an A is. It's a sign for a particular letter in the English language. However, there's a lot of different signs besides just language. So thus the word dog creates a similar sign or a representation in our minds. But what Peirce did is he looked more closely at how there's certain stages to how we get to a more abstract, symbolic form of signs, and that there's certain stages that happen or occur when we do that. So the first stage for Peirce's theory of sign are what are called icons. An icon. And an icon represents something based on its resemblance to something else. So something is iconic for something else because it simply looks like something else. So a landscape painting is iconic for a particular scene, or a photograph of, say, some particular landmark, like say the Eiffel Tower, is iconic for the Eiffel Tower. And the reason it works, the reason icon works is it looks exactly like what it's trying to actually represent. So the way in which we understand a photograph as iconic for the Eiffel Tower is because they look the same. So icons are formed by simply something looking like something else or resembling it. So iconic representation may have co-evolved with imitation and mimicry as a form of cultural communication. So if we think back to imitation and to mimicry, we'll remember that those two things worked based on repeating exactly what it was that you were seeing. So you're imitating or mimicking what someone else is doing. And it's the innovations later that allow for those kind of representations to do more types of things. But if we think about things like a sculpture, a photograph, or a painting, these are things that are iconic for something else or act as an icon because they look the same. So you can use your visual processing to understand what it is that they are. Now the second stage, or another type of sign, is what's called an index. An index. And an index is a sign that stands for something else without a resemblance type of relationship. So what that means is that something can be indexical for something else, but the two things do not look alike. So it indices or indexes some sort of thing. So it acts as an indicator of something else. So for example, a thermostat. When you look at the thermostat and what you see on the thermostat, say like in a room, it indicates what the room temperature is. It is an indicator of it's currently this, say like 70 degrees in this particular room. Now there's nothing visually that you can look at in terms of the numbers 70 to know what that means in terms of the room temperature. There has to be an indexical relationship. It's an indicator of something else. Same thing with a speedometer. If you're looking at how fast you're going, say you're going 75 miles per hour, there's nothing intrinsically related between the numbers 7.5 and how fast your car is currently going. But it can act as an index. It is indicating what it is that you're doing. But there's a more straightforward kind of a relationship. Now, what can get more confusing or what can make things more slightly complicated is that within an index, many signs can be both iconic or indexical based on the context. So if we think about the statue of David, if we think about the statue of David, it's iconic for the male form. I mean, it is really the iconic symbol of what the male body looks like. But it's also indexical as the work of Michelangelo. So it indexes, or it points to, the work of that particular famous artist. And so signs can take on more than one property based on how they're being used. So if we think back to one of the kind of basic indexical things that we've looked at within primates is the alarm calls of the vervet monkeys. These types of calls are really indexical, meaning that when a certain call is given, it indicates a certain pattern of actions to avoid certain kinds of predators. So that is a type of index. I give this call. There's nothing in the call that's really related to, like a leopard or a snake. There's nothing related intrinsically or visually between these two things. But this particular call is indexical for what type of action behaviors I should do and what types of predator I have there, whether it's a leopard, an eagle, or a snake. And so this is probably part of where the evolution of language within primates really came from. There's certain kinds of indexical relationships that certain kinds of animals have, because a call means certain kinds of things. It indexes certain kinds of things. Now, what Peirce says is the thing the way a sign gets closest to language is when a sign takes on a symbolic type of role. And this is where something represents based on a conventional use or a rule that defines its particular interpretation. A symbol is when we have a shared network of understandings that allows us to see this thing as symbolic for something else. And so something like, say, like a marriage ring. A marriage ring symbolizes a marriage relationship. We see the ring and we know that that is symbolic for a particular type of social arrangement between two people. And that makes it slightly different or more advanced than an index, because it's not just indexing something, it's symbolic or abstracting something and talking about a particular relationship within the world. Same thing with the letter E. This is where we get into language, and this is where we get into symbolic language. So the letter E represents a particular sound in the English language. So when we look at different objects, though, no object is inherently one type of sign. It's always going to be dependent on its interpretation and its current use. And these aren't mutually exclusive categories. So just because you're an icon doesn't mean you also can't be an index and a symbol, meaning both types of things can hold. But the context will tell you something about what it is that the role that the sign is currently taking, whether that's iconic, indexical, or symbolic. So Terence Deacon asked the question, how do we get to symbolic forms of reference? So what he argues is that different types of signs are hierarchically related to each other. I mean, there's a certain hierarchy that begins to happen between indexical signs that allows them to go beyond those things and to actually become much more symbolically related. So symbolic reference is built on relationships between indexes, which are later replaced or ultimately forgotten. So understanding an index requires understanding a particular icon. So in a sense, indices build on icons, and symbols build on relationships between indices, or the indexical type of a relationship. So when we think back to something like the work of how Kanzi learned how to do different language. If you remember, he had a certain types of a lexicon, and that lexicon had all these different kinds of symbols, And then those symbols became associated with certain kinds of words. And so what Deacon argues and others is that the first step in crossing the symbolic threshold is by learning indexical types of relationships. So it's the pairing of a particular lexigram with a particular kind of word. And the lexigram shape acts as an indicator of a particular spoken word. So indices are the basis for symbols. We first learn certain kinds of indexical relationships between what we see and what they are indicating. And then later on, those relationships kind of take on a life of their own and become more symbolic in nature. So when we look at how children begin to first learn certain kinds of language, children learn their first words in a very similar fashion. Step one is indexical kinds of relationships. So they pair a particular word with a particular sound, and the word acts as an indicator of a particular spoken word. And many times, as kids are first learning certain kinds of words, the word can only be associated with one particular thing. So, for example, if a child learns the word dog, they may often, or they sometimes will call anything that they see within the house a dog. So they may often mistake a cat for a dog, because at that point, a dog is going to be equal to anything or any pet that they see within the home. And it's only later that the dog becomes fully only associated with one particular animal. And that's also probably where part of this symbolic sort of processing comes, because we can also have the case that the word itself can begin to stand for different sorts of things. So you can begin to associate certain kinds of abstract properties with a dog, and put those in terms of more things like a metaphor for something, or a way to think about the properties of a dog and apply that, say, to a person. It's like a person that you don't like or something like that. And that's the way that a word can take on more of a symbolic reference, because the word itself may indicate a particular animal, but then at some point we begin to be able to use words more kind of metaphorically and abstractly, and the word meaning can change based on the type of context that we're in. So it's one thing to call my dog a dog. It's another thing when I call a person a dog, I'm doing something different. It's obvious that it's not a dog in terms of the animal, but there may be certain things, certain properties I'm associated with the dog that I'm putting metaphorically on that person. And that's when we begin to move into more of a symbolic type of reference. So, how did Kanzi begin to learn symbolic reference? How did he get to that point? The second step is what are called indices of indices. So lexical words can begin to stand in for particular categories. So the word is not just talking about a certain thing, but it can be talking for a whole class of things, a whole grouping of things. So for example, the lexicon word tool can be an index of different types of tools, meaning it can begin to be indexical for a lot of different things, for a hammer, a screwdriver, etc. For a hammer, a screwdriver, etc. So learned indexically, this later becomes replaced or relearned symbolically, because the tool is going to stand in for a lot of different kinds of things. It's going to be a whole lot of tool. In some ways becomes more abstract because there isn't one thing that is a tool. There's a lot of different things that are a tool or make up that grouping tool. And there's just like there's a lot of different animals, there's a lot of different mammals, so there's a lot of different books. There's a lot of ways, and that's when we begin to have something that's more more symbolic, because an indexical relationship is always, to a certain extent, one way. This indicates this. This indicates this. But then once we begin to have room for multiple indices, if you will, that's when we become closer to crossing the symbolic threshold. So how did Kanzi learn symbolic reference? Step 2 was this idea of indices. Had to group together different things into categories that were either things like a food or a tool, then had to sort novel items into those two types of categories. So the new lexigram was associated with certain kinds of categorized items. So it's the way in which we start off with, say, a hammer, a screwdriver, so on and so forth, all these different tools. And then we have a new index, which is the tool index. And then we have a new index, which is the, say, like the food index. And those things contain all kinds of indices within themselves. Because food contains apples, pears, bananas, meat, so on and so forth. There's all these different things. And so that's where we become indices of indices, or that's when symbolic reference begins to take hold. So step 3 for Kanzi being able to learn symbolic reference is that the lexigram now functions as a symbol for a particular category. New items can be associated with that lexigram based on their inclusion in that particular category. Now for a Kanzi, this took hundreds of trials. And actually, some of the research has shown that some chimpanzees were not able to make this kind of representational switch. But Kanzi took a lot of time and a lot of effort to be able to do that. And what we see within human persons is they actually pick up on this really quickly. And probably the reason why they pick up on it is because of the structures of the prefrontal cortex. The prefrontal cortex allows us to make that leap from index to symbol, and to do it pretty fastly and pretty easily. So symbols are higher order associations which are ultimately based on indexical relationships. So thus words like tool can behave indexically but also symbolically. So we learn the indexical relationship and then we relearn it symbolically. So tool becomes something that's not just standing for one thing, but a whole category of different things. And then if we take that even more abstractly, when we think about things like metaphors, the ways in which we can describe different things using language that aren't directly related to the hard definition of something, that's where you get into more of a symbolic understanding of how human language work. So the interesting thing is it took Kanzi a lot of work, a lot of time. Dr. Savage had to work with a Kanzi for years to enable him to do that. And really they had to, in a sense, kind of live together or have a lot of shared space to do that. Whereas children pick that up very quickly. It's still, culture still plays a very important role. But what Deacon's going to argue is that it's also the case that the human brain is set up in such a way to make crossing that symbolic threshold relatively easy and relatively quick for human persons. So for Terence Deacon, in terms of the symbolic species, he would say what makes humans able to process symbols and other forms of abstract thought is that human brains have become what he would call front heavy, meaning there's been an increase in the size of the frontal lobe relative to other areas. And he would say this is especially true in humans in terms of the prefrontal cortex. So when you increase the overall connections between the prefrontal cortex and the rest of the human brain, this allows for symbolic processing to develop easier in human persons in comparison to other species. So what this did, what the increase in the frontal lobe, and especially the prefrontal cortex did, was it allowed more processing power, more cognitive processing power to be devoted to tasks other than sensory representation, which allowed for not just the visual representation, say the iconic relationship between two things, but allowed for it to be in terms more symbolic and more abstract. So here we can see the differences between the amount of space that's devoted to the frontal lobe between different primates within our lineage. And you'll see that the human brain is probably slightly larger than the others. And also the prefrontal cortex is also larger and more, all those bumps and the ridges there are all that processing power being, in a sense, packaged within the frontal lobe. So especially if we look back to the macaque, which you talked about earlier, you can see a huge difference there. Obviously, the chimpanzee is closer to us in terms of the amount of size, and that's probably why someone like Kanzi could actually achieve a certain level of symbolic processing. Deacon argues really is that, and this is all a part of his book called the Symbolic Species, is that human informational processing became more and more increasingly influenced by the prefrontal cortex. Meaning as the human brain evolved, there were more and more interconnections between the prefrontal cortex and other areas of the brain. And what this did is it allowed for a symbolic processing really to dominate other types of higher cognitive functions. And that really one of the achievements really of human cognition is the ability for us to pick up and use symbolic processing so easily and so readily. And so Deacon would argue that we kind of exhibit a cognitive style that is uniquely symbolic. This is actually represented in some research on the prefrontal cortex itself. And so in one paper by McLaughlin and several of his colleagues back from 2003, they actually found that the prefrontal cortex processes stimuli according to a hierarchy of different kinds of representations. So this idea that this hierarchy of different kinds of representations is really the same as or related to the different kinds of representations that we have when we're thinking about different sorts of things, moving from icons all the way up to symbols. And so different areas of the prefrontal cortex include different kinds of informational content, and that informational content is processed slightly differently by different areas of the brain and kind of represent the the hierarchical nature of how symbols work. And so fMRI analysis showed different kinds of activation was based on what kind of information was actually highlighted, meaning that we will process something in different areas of the brain based on what kind of information or the way in which we're trying to process it, whether it's more indexically, iconically, or symbolically. And this is actually represented by kind of the way in which we can use kind of basic, so we start off with basic motor processes, which are more of those kind of reactionary kinds, or the more reactionary types of processes, meaning going directly from the stimulus to some kind of a reaction. But then you can put contextual signals within something, meaning that you can include the stimulus and the context when looking at something. And so that's one of the things that kind of separates the stimulus from simply reacting to something. We can insert in terms of what's the context and what's the context in which I'm in, and how does that affect the way in which I'm seeing something or understanding something. And then finally, I can use an episode, or I can use past events to help me understand the context in which I'm in, and thus what kind of motor response is actually required. And so one of the things that may be going on here is the part of what's happening in the prefrontal cortex is this hierarchy of different kinds of information coming into play when we're looking at something, such that it's not just, in terms of thinking about different signs, it's not simply what something simply relates in the moment. It's also what's my context, and then what's also my past experience with something that comes to bear in understanding something symbolically. So Deacon would argue that the prefrontal cortex acts as a elaborate symbolic a mnemonic memory device, meaning that the prefrontal cortex was, to a sense, evolutionarily designed to process symbols. So it increases the ease with which humans can actually process symbolic forms of information. And so the language itself, if we think about how language works within the brain, it's most likely distributed throughout the cortex in parallel distributed processing networks. And then the prefrontal cortex processes those different kinds of language and allows for the symbolic nature of that language to actually come forward. Now, one of the things that Deacon argues as well is part of what allowed for the evolution of language was the changes you see in the prefrontal cortex. But he also argues that language itself has changed, meaning that as language has evolved as a kind of social system, it's also changed and adapted to the human mind to make it easier to learn, so that language has become more of a user-friendly type of interface. So changes in brain organization co-evolved with the social transmission of language, meaning that persons take advantage of the symbolic nature of the human mind in order to make language transmission easier, more efficient, and really easy to actually pick up. So culture has evolved to exploit the symbolic tendencies of the prefrontal cortex and the teaching of language. So an analogy to this kind of change or evolution of language comes from the way that we work with computers. So early computing that was done was usually done through some sort of a through an MS-DOS prompt, meaning that you had to type in really elaborate types of commands to get a computer to actually do something. And most of the time, these commands were in a completely different language that was very foreign to us. So the first computers relied on learning a completely different and new language to perform different kinds of computations. And so persons had a difficult time trying to type. So persons had to type together difficult symbols and words to try to make the computer do something. But then computing changed over time, and one of the first stops was developing what's known as a desktop. And so a desktop had certain icons on it, and with the development of a mouse, you just had to click on the icons that you wanted. So rather than having to type out a long and elaborate set of commands, you could simply click on something. And this matched more of our basic motor properties, one, in terms of being able to just move a mouse around, but then two, having a visually rich icons that allow us to easily know what it is that we're doing and how to work with them. So in this case, you simply had to point and click two different types of programs. So computing itself was evolving to be more user-friendly, to make it easier to pick up, easier to manage, and easier to learn. Up until the point of now, when we look at something like the iPad, we simply have a very let's say we simply point at different sorts of things, and we don't even need a mouse, we just need our finger. So the next step was to make computer much more user-friendly by using more kind of natural sorts of gestures. So as human persons, we're used to pointing at things. We're used to pointing at things that we want. And so the same thing became true of an iPad. It gets rid of that mouse interface that you have, and now you simply just use your finger and you push on what you want. And this makes it as easy as possible for persons to use the iPad. Such, such is the case that children can actually readily pick up on the iPad and start using it without having a whole lot of instructions to it. And this analogy is similar to what happened within human language. So languages were not designed, but evolved to adapt to human brains, to adapt to the symbolic, front-heavy processing of the human mind. So languages that are easily teachable and survive. Languages that are easily teachable tend to survive, and languages that are difficult tend to disappear. And then children are immersed in very rich social contexts, and those contexts provide continual verbal feedback that allow children to learn language. When we think about the way in which reading has developed, the way in which parents help to teach basic words, the social transmission of language has changed to make it very easy for us to actually pick up. Okay, so that is the lecture on the evolution of language, and we'll see you next time.